In this movie we'll take a look at 3D space and, to be precise, the X, Y, and Z axes and what they do to each other as well as in 3D space. Now for example, we have a little wall here, and every game object in 3D space has its own X, Y, and Z, as you can see up here. Now the X, Y, and Z position is what keeps our object in 3D space and determines where it is in 3D space. Now, it is best to remember exactly what X, Y, and Z do and memorize it by heart. To make it a little easier, most 3D applications use the same color for X, for Y, or for Z. Now let's start with the easiest one, which is Y. Y is always represented with the green color and means up. It is easy to remember that Y is up because the letter Y is the longest one from X, Y, and Z. So if I take, for example, the Y position and I start counting upwards and change it from 0 to 1, you can see that the wall starts floating up from the air and it's no longer positions on the terrain. However, if I start moving it down into a negative number, for example, -1, it goes down into the floor. X is also not very hard to understand, although it's a little more complicated to remember than Y, but X is always towards the right of the object. So it's basically your horizontal axis, but mainly going towards the right. X in most, if not all, 3D applications is represented by a red color, and if I would increase the number of X to say 57, you can see that the cube starts moving towards the right. And if I start counting down, for example, to 54, you see that the object starts moving towards the left. So same principle as X and Y, pretty self-explanatory, but it might be best to remember that the red color is always X and X is always towards the right. Now for Z. Z is new in the games world. Not that new, I mean 3D games have been around for a while now, but games used to be two-dimensional only, and then we only had X and Y. But now, with Z, it is obvious that we have depth in games now, so depth is always away from you, and that helps you remember that Z is always into depth. Now, Z is represented by the blue color in most, if not all, 3D applications. And of course, if I would increase the number of Z, you can see that the cube starts moving away from us, and if I decrease it, it comes back into view. Which could be quite cool if you want, for example, something to pop out at you from the screen. If you were to make a two-dimensional game with Unity, which is entirely possible and up to you, in script just ignore the Z variable and stick to X and Y. Now, you still have the effect of 3D as your camera can see things in 3D, but if you fix the camera to only look at depth and then keep your script bound to X and Y, then it's entirely possible to make a two-dimensional game with a 3D feel with Unity. There's a couple other more things that you need to know. Remember in school when you needed to draw X and Y axes and then do calculations with formulas and those sort of things? Well, it's exactly the same in 3D, except that it's cooler because it has to do with games. Now, remember how you would note these numbers on your sheet of paper? Is X, Y is the way you would note it. Now in 3D world, this is called a vector. X, Y is a vector notation. In 3D, of course, it adds a third one to the mix, X, Y, and Z, and in Unity this notation is called a vector 3 variable. So not a vector but a vector 3 because it has to do with 3 numbers. Now using these vector 3's can be extremely powerful in three-dimensional engines, but it can also be a headache every now and then. So before you start changing anything in your script, let me show you in the next video what exactly you can do with this.